Welcome to Brain Vision.
In this question, there are four forces acting on the crate. The weight force, the normal force, that is the force exerted by the floor on the crate, the horizontal force that we will use to move the crate, and the frictional force that tries to make the crate not move. And we are interested in the horizontal movement of the crate. So we begin this question by applying Newton's second law to the horizontal axis. So let me choose my referential as being that everything that is pointing to the right is positive and everything that is pointing to the left is negative, and I will call the horizontal axis X. Then Newton's second law, when applied on that axis, gives the following. The net force is equals to the mass of the crate times the acceleration of the crate. But the net force acting on the crate on that horizontal axis is equals to the applied force minus the frictional force, and this is equals to the mass of the crate times the acceleration. We want to calculate the force F, so F is equals to the mass of the crate times the acceleration of the crate plus the frictional forces. But note that on both situations we are interested, the crate is not accelerating. It's either just starting to move, so it's not yet moving, so the acceleration is equals to 0, or it is sliding with a constant velocity. So again, the acceleration is equals to 0. Therefore, A is equals to 0, and this tells us that the applied force is equals to the frictional force on both situations. So, on the first situation then, the force is equals to the frictional force that acts on the crate when it's just starting to move. So if it's just starting to move, we will have to use the static friction coefficient to calculate the frictional force. So the frictional force is equals to the static frictional coefficient, so mu s, times the normal force that is acting on the crate. But note that the normal force is equals to the weight force because the crate on the vertical axis is not moving, it's standing still on the floor, meaning that the normal is equals to the weight force. Therefore, we have that the frictional force is equals to the mu static times the weight force. But the weight force is equals to the mass of the crate times the acceleration of gravity. Then the problem gives us the following values. So the static frictional coefficient is equals to 0.76. The mass of the crate is equals to 60 kilograms. And we will consider the gravitational acceleration to be equals to 9.8 meters per second squared. Then the force that is necessary for just starting to move the crate is equals to 0.76 times 60 times 9.8, which is approximately 447 newtons. Now, on the second item, we do the same thing, the same calculation, but now we will use the kinetic frictional coefficient, because on the second situation the crate is already moving. So in the second situation, the necessary force is equals to the frictional force in this kinetic situation. So this is equals to the kinetic frictional coefficient times the weight force, which is equals to the mass of the crate times the acceleration of gravity. And the problem tells us that the kinetic frictional coefficient is equals to 0.41. Therefore, the necessary force to keep the crate moving once it's moving is equals to 0.41 times 60 times 9.8, which is approximately 241 newtons. So note that keep moving the crate is easier than making the crate start moving. And this is true for almost everything you try to move.